Testing, testing.
Yeah, you're loud and clear. Nice office space you've got there.
It's the future, man. One day you'll get there.
One day or die trying, eh?
How's it going? You look so relaxed.
All right. What can you do? Just finished off working. Now I'm just switching off.
I literally just got off Zoom to get back onto Zoom. What fun.
Let's just see what the settings are.
So apparently you can make it so that only the host can share their screen, which I think is probably a good idea. Hi, Nakita.
Yeah, should be.
Hi, how are you?
Good and you. You ready?
Born ready.
Wow, that's quite an attitude.
Hey, Evels. Hey, Nakita.
Hi, how are you?
How's it?
Hey.
Yes, that looks like a boss chair.
Oh, yeah, it is. Wait, why can't I have virtual backgrounds? Is it disabled for you too?
You need a real machine, you know, like a Mac.
What do you mean a real machine? Come to the second online Dev UG of the year. I trust everyone's doing well and surviving the lockdown. We are on level 4 now, hopefully going down to level 3 soon, but we'll see how that pans out. Tonight, we just want to quickly say thank you to our sponsor, Entelect, for keeping the user group running. And I also want to welcome my co-host, Ezra, who's going to be introducing the speakers.
Okay, I guess we can get going. It's 6:05. Yeah, thank you everybody for coming through. I see we've got quite a few people that accepted today already. Yeah, let me introduce our speakers. We're going to have 2 sessions today. The first session is going to be with Nakita and Renier telling us a little bit about the Entelect Challenge for 2020, running through architecture and just telling you a little bit about it and some great things that you can do there. And Nakita and Renier are both software engineers over at Entelect. And our second session will be with Ewald, one of our leads for the developer user group. And he's going to be running you through a few things about Kotlin. I believe there's going to be live coding as well, which is always fun to watch. Over to Nakita and Renier first.
Okay, hi guys. I've added the Entelect Challenge trailer video that you're going to watch. So if it doesn't play very well over Zoom, please follow that link or just check out the link once this session is complete. Okay. Hi, everybody. I'm Nakita Reddy.
My name is Renier Roux.
Okay, and we're here to tell you about the Entelect Challenge. As you've just seen from our video, this year our game is called Overdrive. What is the Entelect Challenge? The Entelect Challenge is an annual coding competition that Entelect has been running for the last 9 years. Entelect runs the challenge every year as a fun way to bring the software community together, but also to demystify the world of coding and artificial intelligence. The competition is designed for anyone with a basic level of programming who is interested in the world of machine learning. There are 6 starter bots for this year's challenge in a range of languages, which are .NET Core, JavaScript, Java, Lisp, Rust, and Python. This year's theme is racing. Each player will code a bot that they will race against each other to see who can get across the finish line first. So we have 3 commands that are available to you. We have speed, where your bot begins with a speed of 5. This means that the car will move forward 5 blocks each round. With speed, you can use an accelerate or decelerate command to control your speed. Secondly, we have turning. This will allow you to change your lanes. And finally, we have power-ups. You'll be able to pick up these power-ups and use them in the future against the other bot. If both bots cross the line, the finish line at the same time, then we will look at the points gained along the way to decide a winner. The map that we have is a 2D array of 4 lanes, as you can see in the bottom block. Each lane is made up of consecutive blocks, which has either a power-up, an obstacle, or is simply empty. If you look at the top block, you can see what each of the little blocks mean. So we have oil spills, a boost power-up, etc. The map is about 1,500 blocks in length. The state file that the players are given has limited visibility, and the players will only see about 30 blocks at a time. Okay.
Let's take a look at our infrastructure. In an effort to save money and have a scalable system, we have continued to use the completely serverless infrastructure from last year. We use a combination of different Azure products available to create an environment where we dynamically spin up containers that will compile bots and run matches as they are uploaded. This allows us to pay only for what we use and even get the first couple of usages free every month. A quick overview of the infrastructure. The website or player portal is a single-page application served from blob storage. It is backed by a suite of Azure functions that act as API. These functions communicate to our Azure storage solutions to update, insert, and fetch all the necessary information. We use 3 storage solutions. Firstly, blob storage. It is used for files like bot source code, compiled code, and logs. Secondly, we use table storage. This holds key value-based information like user entries, bot information, and the status of bots being compiled and matches being run. Lastly, we use queue storage. This is mostly to hold onto tasks that need to be run by our logic apps. Now, the logic apps handle bots that are uploaded to compile and run matches during reference matches and tournaments. They do this using container groups. Container groups provide the necessary resources and isolated environments for the bots to compile and the matches to successfully run. Let's take a look at a bot submission flow. The player's first entry point is the player portal. When they upload a bot, the player portal calls a function that verifies their identity, inserts a new submission entry, creates a staging container reference, and returns the upload URL to the player portal. When they upload the bot, the player portal can then use the URL to upload the zip file containing the source code to the staging container. This creates a new blob storage create event. When the event fires, it calls another function that gets the submission details and environment settings from table storage. After the function got all the details, it adds a new bot compile event to the event grid, which gets picked up by the compile logic app. This logic app then compiles the bot and saves the compiled code and logs to blob storage, so we can reference them later. Once the compiled code is saved, the logic app fires an Azure function and ends. This function updates the build status and the submission and creates a new match entry in table storage. Once it's done interacting with table storage, it adds a new match event to the event grid. This event is picked up by the match logic app and handles the running of that specific match. Finally, once the match is done, the logic app calls the final Azure function that updates the match details and the submission details. Bot compilation and matches that run are handled with container group instances. We spin these up as and when we need them to reduce cost. We use Azure container groups to ensure that the bots get dedicated resources during a match. The containers also allow us to run bots in various different languages. We currently support .NET Core, Java, JavaScript, Lisp, Python, and Rust. The compile logic app starts a container group instance with the correct environment for that specific bot. However, the match logic app starts a container group instance containing the game runner, game engine, referee, and the two bots. And in the case of a match triggered by a new upload, the player bot will be playing against the reference bot.
Okay, now that you know about our infrastructure, I'm going to tell you about the maps that we use and the fairness and the symmetry. So this is what a map looks like when we generate it randomly. As you can see, there's more mud on the bottom half than in the top. This means that the player starting at the bottom half will have a tougher race line. For those who are not familiar with it, Perlin noise is a technique used to produce natural appearing textures on a computer-generated surface for motion picture visual effects. The development of Perlin noise has allowed computer graphics artists to better represent the complexity of natural phenomena in visual effects or for the motion picture industry. So when this is compared to normal white noise, you can see that Perlin noise creates clear shapes, and these shapes are ideal for creating the boundaries or the dirt that we need for those maps. In last year's game, which you'll see just now, this presented a problem. If we generate the entire map randomly, instances occur where one player has significantly more dirt to dig through, and thus arose the fairness problem. We solved this issue by making the map symmetrical. We mirrored the left and the right-hand sides, giving both players an equal amount of dirt to start with and dig through, and thus solving the fairness problem. Here in 2020, we saw another fairness problem arise from using a randomly generated map. Here, however, we can't just make the map symmetrical. If you look at the second block on your right, you can see that we end up with a track where the bots won't move over to the other half because the map is the same on the top and the bottom. So seeing as they lose precious speed by moving over, it makes more sense for them to just accelerate in their lane. This meant that the two players will end up racing on their own two halves of the road. This would defeat the purpose of having any collision logic in the game. So our final solution was to run two matches instead of one, both with the normal non-symmetrical map and both with the same seed for both the maps. However, in the second race, we swapped the bots' positions. This meant that they both have a race in the favorable starting position, if there was one. The result is, if player A wins both, then clearly it was the better bot. But if they each won a single race, then we looked at the scores and the bots accumulated during the races. This meant that if one bot clearly made better decisions, like avoiding the mud and picking up power-ups, then it was the better bot.
So now that you know about the challenge and how it works, how do you go about getting started? You can go to challenge.intellect.co.za or just Google Intellect Challenge. You will be presented with this website. On the homepage, you will find a screen which will allow you to download the starter pack. Once you've downloaded the zip file and extracted the files, you will find everything that you need to get started. The most important things to take note of, however, is the starter bots, which you can pick any one of them and start adding your own logic. The game runner config, which you need so you can configure which bots are being run locally, and the run.bat so that you can kick off games locally. In the starter bots folder, you can pick your favorite language, make a copy of that bot, rename it to whatever you like, and find the bot.json file inside of it. The bot.json file is important because here you need to change the default fields to your own details and the details of the bot. Remember to set the bot location and bot file name if you decide on making a custom project. So to get started, let's configure the game runner to run against the reference bot. For this, you need to set player A so that it points to your bot directory, and make sure that player B is the reference bot directory. Now, by default, player B will already be set to the reference bot directory. Finally, you can run the run.bat file. This should open a console window that runs the match while giving you a visual representation of the race. In the console window, you will see a few things. You will see every round as it's being run, which will show you the state of your bot, but also a small image that represents the state of the race. This image is generated using the characters we mentioned earlier. And the commands given by each bot will also be shown for each round. We advise you to test your bot locally like this before uploading it to the player portal to ensure that it works as intended. Now that you have a working bot of your own, you can zip up your bot folder and upload it via the player portal. But remember, there are a lot of entries, and if you want to win, you will need to continuously improve your bot. We don't limit the amount of submissions because we want to give you all the chances you need to make that prize-winning bot. And finally, if you have any questions, queries, or problems, you can ask for our help on the forum. Just Google Entelect Challenge Forum.
Okay. These are the tournaments that we have for this year. We have box carting, which has already happened. We've had it on the 2nd of May. The Furious and the Fast 42, which will take place in a month's time. So you have enough time to get your bots ready. We have Virpa Wanna Dice Chana. That's happening on the 8th of August. And finally, we have Carmageddon on the 26th of September. This mini playoff series will provide more of an opportunity for contestants to win. As per last year, the contestants will get the opportunity to win a golden ticket in each of the first 2 mini playoffs. And in the 3rd mini playoff, the top 6 will win a golden ticket. This makes up the final 8 that will compete in the Comic-Con event, final event. Since this year we have our pandemic and we aren't really guaranteed Comic-Con, we will be looking to Comic-Con to see how they're going to structure their event and how it will happen. So please have a look at the Comic-Con website and keep up with Entelect, and we'll let you know when we know what's happening. One thing we would advise you to do is submit your bot in advance. If you try to submit, let's say, an hour before the submission deadline, which is midnight on any of these days, and something goes wrong, it will cause you a lot of unnecessary stress. So you're not just playing for nothing, you're playing for prizes. In the 1st and 2nd tournament, as I said, the first prize is a golden ticket to the main challenge, and the 2nd and 3rd would be a cash prize. The 3rd tournament has the top 6 getting golden tickets for the main challenge. And in our main challenge, you can win a cash prize of up to 70,000 Rand. Finally, we have something called the University Cup. The top team in the University Cup gets gaming laptops. So what is the University Cup? This year, the Entelect Challenge University Cup will be hosted for the 3rd time. In previous years, we have hosted the tournament at universities, but again, because of the pandemic this year, we'll be hosting it online. Since students have exams and cannot compete the whole year, the University Cup is a one-day hackathon where teams of students from various universities around the country are challenged to solve a coding problem where they can win prizes for themselves and for the university.
Thank you to our team for making all of this possible. They have put in a lot of extra hours to ensure that we have an amazing challenge for you guys. This is where you can find us if you have any questions or you need to know more about the Entelect Challenge and our company as well. Thank you for joining.
All right. Thank you very much. Looks really interesting. I'm sad that I can't enter since I work at Entelect. But to anybody that's looking to make some extra money or you just want to build a bot, go ahead and enter. Go through to challenge.entelect.co.za. Yeah, I guess next we've got, oh, Enrique has something to say.
Yeah. Just before we carry on, so if anyone has any questions for the Intellect Challenge talk, you can either raise your hand or type Q in the chat or type out the chat message. We'll just wait a minute or so to see if anyone's got questions, and then I'll unmute you if you want to chat. There's a question from Earvolt. It's saying, he's asking, is it open to everyone, the challenge?
The Intellect Challenge is open to everyone, sadly, except for members of Intellect and their relatives.
Cool. Then just in case anyone else is busy typing out a question, we're going to do a short intermission for some prize giveaways. So normally we'd give out JetBrains prizes at the different user groups in Joburg and Pretoria and Cape Town, but we only have one combined one. So tonight we'll give away 2 JetBrains licenses, and the question will be, and you'll have to type the answer. So get your chats open ready. The first 2 correct answers will get the prize. You can just private message me your email address afterwards. And the question is, what day of lockdown are we on? So there's some numbers there that are close, but I think they're still off. Getting very warm there, Tyler. There we go, okay. I see the 2 correct answers. The answer is 55. So that's Craig and Tyler. You can private message me your emails, and I will make sure to get in contact with you to send you your JetBrains.
Enrique?
Yeah?
Sorry, it looks like James got it first.
Is it James? Did I misread? Okay, I'm looking at the order that I got it in here. So I got first from Craig, and then Tyler, and then James. Okay, in that case, we'll send out, I think we can organize a 3rd one. So James also can send through his email address. Actually, I see he's registered with his email address, so I'll sort that one out. Cool. Then back over to Ezra.
I think I'll hand right over to Earvolt, who's going to hopefully break some stuff for us.
Yeah, live coding. That's always a great idea. So first challenge is going to be to share my screen. And let's see what happens. And we're still on Zoom. Right?
We can see your screen.
All right, awesome.
Your IDE.
That's a good start. So what I'm going to do is I'm going to sort of talk through what I'm doing as I'm doing it. And if people have questions, I guess the chat will show up, maybe not. Yeah, I can get the chat up and running at some stage. I'll take a look at it now and again. Okay, so let's get cracking. So the whole point of what I'm going to do today is write something that runs in the browser using the Kotlin language. Now, if you have any web development experience, this will look familiar with a slight flavor of Kotlin thrown in. Here we have a little Kotlin file, which we can ignore for now, because I want to jump into the HTML. I've made some notes just so I can remember what I'm supposed to do. So the first thing we're going to need is we're going to need a canvas element. And all this is very standard stuff. So this is exactly how you would do it normally. Nothing fancy here. What I'm going to do is I'm going to give it an ID. And I think I should give it a width and a height. And let's make it let's see if we're lucky. So what's nice about the IntelliJ IDE is that it does a whole bunch of things in the background for me. So let's see if that still works. And we should now have something that pops up. And oh my hat, it's a Kotlin. All right, awesome. So believe it or not, there's a canvas in here somewhere. But what we're also doing now is we are actually running Kotlin in the browser, which is really cool. It means that you can write JavaScript code without having to know anything about JavaScript. I'm not perfectly happy with how that thing is styled, so I'm just going to add a style. And again, this is plain vanilla styling as you would write for normal apps. So let me put this in. And bear with me, I'm not a web developer. I believe that this is the second worst way of doing this, but it works for me and it does what I want it to do. And if you want, you can put in a pull request on the repo that I shared to help me do this in a better way. And then I will steal credit for your cool code on my next demo. And let's see what this does. No, put it close up. All right, awesome. So we're not drawing anything yet. So that's kind of what we expect. So now we have our basic HTML and CSS structure in place. And now we want to start doing the thing that we would normally do. I'm going to switch my camera off. Can you still see my screen?
Yep.
Awesome, thanks. I'm just noticing some power drain here on my machine. So now we're going to get to the part that you actually want to do in JavaScript normally, but because like me, you might not know JavaScript well enough to be comfortable with it. And I like the safety net of a statically typed language, whereas in JavaScript, everything can be anything. And I tend to make a lot of very interesting mistakes there. So what I'm going to do now is I'm going to set up some values that I can work with. And the first one I'm going to do is I'm going to get a handle to that canvas that we created. Why is my Kotlin not completing? Okay. We'll get there. Maybe. What am I doing now? Let's see. Close that. Okay, so what you can do in Kotlin is you can set up values, so statics, by accessing the DOM as you would normally in JavaScript. But you can also tell Kotlin what it is. So we can say what we are working on here is a value canvas, which is a variable, but it's a type HTML canvas element. So now when we work with it, I just want to fix this one import issue. some reason it's not building. I just want to get okay. I'm just getting the build to run. And this is the fun part of live coding. Oh, there we go. It's busy installing all the stuff that I want. That's much better. Okay. All right. So now, in theory, if I go to Canvas, no, still not happy. Hello. Too many toolbars in the way. For some reason, it's completely freaking out now. I don't know why. What I'm going to do is I'm just going to close the project and come back into it and see if it will get my imports right. I have a backup copy if this doesn't want to work.
You keep running the build. Just change the drop down up at the top.
Oh, sorry. Okay. It seems to be working. I just don't know why it's not doing the autocomplete anymore. Doesn't matter. The next thing we want to do is we want to get a handle on the context of that canvas. And now that we know what it is, we are sure it's a canvas element. We can safely get the context as you would in JavaScript, the exact same way. But we can say it's a rendering context. So this is a little bit like TypeScript, where you can start adding types to variables. So this helps the compiler to help you figure out what you can and can't do with something. So let's see. We've got the canvas, we've got the context. So now we've got that. We probably need some classes to store some of our data that we need. And the first one I'm going to set up is a velocity class that's got an X value and a Y value. Next one, we're going to need something that will store a value that we keep. And notice that we can use standard Kotlin data classes here. So anybody that's got any Kotlin experience whatsoever, this will immediately feel familiar. We're gonna have a little spaceship that's got a little size. And then this is not a data class because we're actually gonna be changing things in it. So this will be the position. And we're gonna make it default position and all right. So there we go. We've got our data classes set up. Next thing we're gonna want to do is we're gonna want to respond to user input. So let's create a function. Call it setup event handlers and have some event handlers set up. And we want to add an event listener. Now, if you've done any web development, this will look very familiar. So the link between Kotlin and the DOM elements is really strong, and they really worked hard to keep it as close as you would have in JavaScript or TypeScript. And what I'm going to do here is I'm just going to pass it in and say I'm going to create something called handle key input with the event as a keyboard event, I think, yeah. And let's do the same for the key up. So when someone presses a key, we're going to do something, and when someone releases the key, we're going to do a little something. So there's our event handlers. Next thing we're going to want to do is look at our spaceship. And this is where most of the real work is going to happen. We're going to have a standard little Kotlin object that's going to handle things like drawing, changing position, all that kind of fun stuff. So to save us a little bit of time, instead of typing that whole thing out, what I'm going to do, because I realize we're running out of time, I'm just going to copy a part of this over, which is this big fat one. And then we're going to start adding little missing bits. I'm a little bit concerned why this IDE is suddenly not showing what I was hoping it would show. Anyway, let's do a bold and see what it complains about. There we go. All right. Yeah, for some reason it's complaining about the right things, but it's not showing it in the IDE. Probably something to do with the screen sharing. Let's not worry about that too much.
Ewald, you've just got a question. How is this running? Is it being transpiled into JavaScript or compiled as a WebAssembly?
So that's a really good question. So currently, under this, the default state of Kotlin, this is Kotlin 1.3.72, I believe. Yes. So under this version of Kotlin, it's still running as plain JavaScript. So it doesn't do any optimization into WebAssembly. There is some work that's happening to allow you to target WebAssembly with Kotlin as well, although that project has slowed down quite a bit, and I haven't seen much movement on it in the past 6 to 8 months. There is some work though, and I have had some success getting some WebAssembly work done in Kotlin, but it's not very mature. There's no tooling around it that really works that well. It's all command line driven. And when something goes wrong, there's no debugging for it yet either. So I would steer clear of that part for now. This, however, works really well. And what it does, and I can show you when the project runs. Let's just see what it complains about. That's really weird. I must be doing something very wrong. But anyway, what I'm going to do instead is I'm just going to bring this over. Otherwise, we're going to sit here the whole day. And then we can rather walk through the code. All right, so.
Follow-up question, sorry, Andre. He's asking, just to confirm, is your Kotlin code being converted to JavaScript in order for it to run?
Yes, that's what I'm about to show you.
Cool.
Remember when I was in the IDE and I edited the index file, the HTML file, See here, it references a little JavaScript source file. And if you're in the browser, you can also click through to it. Hello. I don't know. There we go. All right. Let's just make this a little bit out of the way. So there's a whole bunch of things that happen on your behalf, and you can see it uses Webpack to build a JavaScript Kotlin-based wrapper. And if you go through all of this, you'll start reading a whole bunch of things that you actually get from a lot of very popular Node libraries that are included. I'm just trying to find our stuff. It should be around the bottom here somewhere. Okay, it doesn't do the wrapping that well, but anyway, it uses Webpack to take all the JavaScript or all the Kotlin that you wrote, converting it to JavaScript, and then packing it all together as one single JavaScript file. So all the libraries that you include, so all the different Kotlin classes and things that you write, everything that you get here gets translated to JavaScript, and then that JavaScript gets executed in the browser. You can also target Node.js. I haven't had a lot of success with that, but this seems to work quite well. So now if we take a look at what's happening, we've got a little triangle that flies around. Let's go take a look at what actually happened. Just want to stop this running. Okay, so here we've got the normal document add event listener. So this is pretty much how you would do it in JavaScript as well. The only difference being sending in these as identifiers or qualifiers next to variables. This means that when I'm working inside this handle key input, I know that it's a keyboard event that comes in. So I can do things with the event. I can say event, now this, for some reason it's now stopped working, but normally you actually get all the correct properties for that event. So you see what is available on that particular item. You can, oh, that's the problem. It didn't download the declarations properly. There must be some kind of internet issue. So the whole thing is that because you are identifying types, Kotlin knows what to do, and Kotlin knows how to protect you against calling methods or properties on that particular variable that does not exist. So in JavaScript, it's easy to get confused with something and maybe misspell it or think that there's a height or width property on something and there isn't. But in Kotlin, it will then, when you try to compile, it will actually stop you at the compile process and say, sorry, you can't do this. It's not available. So you don't get that problem at runtime. You hit that problem at compile time. So at runtime, you're actually safe from that kind of thing. The rest of it, and I will upload all of this code to the repo as well, but the rest of it reads just like it would in normal Kotlin. The only difference being that it targets the DOM and it targets things that happen in the browser. There's you can do little things instead of the context.begin path, context.move to, context.line to. Instead of that kind of JavaScript style code, you can do the with context Kotlin style code, which to me makes the code a little bit easier to read. So all of these actions are happening on the context, but I don't have to type all that code that you would normally do in JavaScript. So it feels a little bit cleaner. The only thing that I have found that irks me a little bit about it is it's very difficult to understand the JavaScript that this throws out at the end of the day. I'm trying to find the actual JavaScript and builds. Okay, so here we've got the JavaScript nice and formatted. And you can go and read through all of this. There's not a lot you can do, unfortunately, because this is part of the compile process. But if there is something very wrong, you can go read what the JavaScript is that it generates and figure out why is it not generating what you thought it would read. And you can see here our document listeners that we added. It builds the lambdas on our behalf. So instead of passing in dynamic, it takes the lambda that we built and it just starts building a lambda 0, 1, 2, 3. It just continues like that. And here they are. Here's the first handler. Here's the second handler. There's a little spaceship, and we can see all the little this properties. So you don't have to worry about knowing and understanding how this works anymore, which is a really big help. Downside to this code, though, is it's still targeting, from as far as I can tell, it's still targeting ES5. It's not targeting ES6. So there's some of the code that could be more optimized with lets and constants and things, but it's not there yet. Apparently, in the newest Kotlin 1.4 early access, there's a lot of changes around the JavaScript code, and it's heavily optimized for performance and compatibility with modern browsers with regards to ES6. But it's not been released yet, so we don't know what's going to make it and what's not going to make it into the final release. I am hopeful, though, that they will finally bring the ES6 code out, because that just makes all of this a little bit cleaner and a little bit better. So, any questions?
Cool. I'm going to let people, allow them to unmute themselves. So you can either type a question out or unmute yourself and ask a question. So I've got a question here, Volt. Why Kotlin instead of TypeScript when there is TypeScript?
TypeScript is amazing. The challenge, though, is that in my day job, I write backend Kotlin code, and for mobile apps, I write Kotlin code as well. Even on iOS, I write Kotlin code. So the learning curve is a lot lower if I can stick to the same language and just have to learn a little bit more about the DOM and how it works. So basically it's down to old age and laziness, I guess.
We are the asteroids.
How old are you?
Too old. And the asteroids is for the next talk. Or how did I say? It's for the user to implement. Okay, I think we can call it.
Cool. Thank you, everyone, for joining us. Thank you, Yevold, for the presentation. Thank you, Renier and Nakita as well for your presentation. Thoroughly enjoyed all of it, and hope to see you guys all next month. We'll probably be scheduling it for the third Wednesday again like this, and we'll make sure to announce it a bit earlier this time. Have a nice evening, everyone.
Thank you. Thank you so much for your time.
Thank you very much.
Thank you.
And I will upload the code to GitHub in the next 5 minutes.